Hi, so we've learned what confidence intervals are for, how to calculate them, and now we're going to learn how to calculate a confidence interval for a proportion in Excel. Usually we're going to start with a pivot table when it comes to a proportion, right? So a proportion is also comes from a relative frequency, right? Table. So we're gonna review how to get your data in an Excel spreadsheet, and specifically how to get a pivot table from a data set to calculate a frequency distribution for your variable of interest, or a proportion for your variable of interest. From the pivot table, we'll get the sample size n, we'll get the sample proportion p, and well, here you can get this from Excel, but you can also remember that for 95% confidence you need a z of 196. For 99% confidence you need a z of 2.57. And we will use for the formula to calculate a margin of error and then the confidence interval using Excel. Just as a reminder, this is the formula. This part is called the margin of error. The margin of error tells you how far you may be from the population proportion for the degree of confidence you chose. So let's start with an example. Our research question is, what percentage of CHHS students strongly agree with the statement, "I like statistics"? Now, notice that the research question is about the population, right? CHHS students. What percentage of CHHS students, what percentage of the population of CHHS students strongly agree with this statement? We have sample data, right? We took a survey of 50 students out of 200 plus that we have in CHHS. We have that sample data, but the research question is about the population. So we have the sample data, but we're going to create a confidence interval for our estimate so that we can talk about the population of CHHS students. And suppose that we want to be 95% confident in our results. Okay, now let's move to Excel. This is what we have on the data set. I introduced all the 50 surveys here. That's the first survey. This is the question like stats. Right? If you go to the code book, you can see like stats is responses to I like statistics. These are the values you can take. And specifically, we want to know the proportion of students who strongly agree with this statement in the population. Okay. So we're going to insert the pivot table. Right. Now you don't see it now, but I'm going up to the data window and then to pivot table. And Excel has already selected the data set. I am going to put this pivot table in a place that I already have here. I'm going to put it here. So on an existing worksheet on this place, and then hit OK. Alright, now on this worksheet that I decided to put my pivot table, I have things that are ready. I have the formula for a population proportion, just as a reminder of what we need to do. And I have all the steps that I need here to fill to calculate the confidence intervals, right? Alright, so this is the question of interest, like stats. I'm going to drag it into the row labels. Now one of the problems is that we have this is not ordered, right? And it's an ordinal variable, so we want them to be ordered. So I'm just going to move this to make it ordered, right? Strongly agree, then probably not sure. I'm just clicking and then dragging them. Whoops, it was supposed to go here. And then disagree, and then strongly disagree, and then the ones that didn't answer or the ones that answered incorrectly, right? Right now we're going to drag this in the values, and we're getting a count for this variable. So we have 5 respondents said, out of the 50 surveys, 5 of them say, students said that they strongly agree. Answered strongly agree with the statement that they like statistics. Now, we have 4 students that didn't answer the question. They did not answer the question. We don't know if they agree, disagree, or are not sure, or they strongly agree, or any. So we're going to filter this out. I'm going to click here. I'm going to take out the blank and incorrectly filled. We're not going to include those in our analysis because we don't know what they really think. That leaves me with 46 observations, right? 46 observations. That is my sample size for this question. So I'm going to put here n is 46. Now, what is the sample proportion of students who strongly agree? Well, there are 2 ways to calculate that. We can actually calculate it by hand by dividing 5 by the sample size, 5 by 46, and that gives us the sample proportion is 0.11. Or we can ask Excel, right? We can right-click here on the numbers, field settings, options, and show the data as % of column. Then hit OK, and you have that about 11% of the students strongly agree, of the sample, strongly agree with the statement that they like statistics. All right, so the proportion here, we're going to put 0.11. Z, that goes in the formula for a 95% confidence interval, is 1.96. And now we're going to start the calculations. This is all we need. The rest is just simple math. Okay, P is equal to that. 1 minus P, well, it's equal to 1 minus P. P times 1 minus P equals P times 1 minus P, right? I'm here. This is P, this is 1 minus P. I'm multiplying both of them. Now, P times 1 minus P divided by N, right? To get all of this that is under the square root sign. Okay, so this is this thing divided by N. Now, the square root of all that. Okay, so this is equal to the square root is QRT of this number. Open parentheses, put the number, close the parentheses, and that's it. Now, this whole thing we need to multiply by Z. So equals to Z, that's Z, 1.96 times that. Now, remember what this is called? It is the margin of error. That is the margin of error. I'm just going to copy that number there. This is our margin of error. And it tells us how far our estimate may be from the population proportion, given the confidence the confidence level that we chose. So to calculate the confidence interval for the lower bound or the lower level, I just have to subtract the margin of error from the population proportion. So this is equal to population proportion minus margin of error. And for the upper level, that's the UL, the lower level, the upper level is equal to the proportion plus the margin of error. And that is our confidence interval. That is our confidence interval. This was our proportion. The lower level is 0.02. The upper level is 0.20. Right? Now let me I'm just going to make this a proportion instead of a percentage to make it more clear. Just a number with 2 decimal places. Sorry about that. So we have, this is our population proportion, and we are 95% sure. This is our sample proportion, and we are 95% sure that the population proportion lies between 0.02 and 0.2. In other words, we are 95% sure that the percentage of students, of CHHS students in the population who strongly agree with the statement that they like statistics is between 2% and 20%. Right? We got this sample estimate, and the population proportion, we're 95% confident that falls within 0.09 of that. Right? This is not our margin of error. We're 95% sure that our population proportion falls about 10 percentage points above or below our sample estimate. That is how we calculate a confidence interval, and that is how you can talk about a population proportion starting from a sample result. If you want, you may need to go back to the other videos. You don't remember, where this 1.96 comes from, or how you're interpreting this, or what the margin of error means. This is specifically how to obtain this in Excel. If you want more clarification on what these things mean, go and watch the previous 2 videos, the intro to confidence intervals and the confidence intervals for proportion. Thanks for watching.